Hello and welcome dear viewers to the video on sink factor in the dissolution testing. So as we know, sink conditions are required for dissolution testing, and based on the solubility we can achieve the sink condition. Sink condition and the sink factor is important for ensuring the accuracy and relevance of the dissolution results. Generally, if the dissolution is performed without having the sink condition, the dissolution results may not be reliable and may not be the reproducible. The dissolution becomes strength dependent because of the changes in the sink condition for low soluble API formulations. If the formulation contain the low soluble type of APIs or drug substances like BCS class 2 and BCS class 4 drug substances, that time dissolution becomes very critical. BCS class 2 and 4 APIs formulations may require the use of surfactants for getting the sink condition in the standard media volumes with standard dissolution conditions. So if non-standard dissolution conditions are required to be followed, lot of justifications are required. Generally 900 ml of the media volume should be used with the paddle basket apparatus with the paddle speed of around 50 rpm or 75 rpm and basket with the 100 rpm. So selection of the apparatus and speed is the part of dissolution method development, and that will not be discussed in detail here. Sink condition means dissolution media can dissolve the 3 times of the quantity of API contained in the highest dose strength. So if you are having multiple dose strength formulation, that time consider the highest strength. API dose in the highest strength, for example, is 500 mg. Then the dissolution media of around 900 ml as a standard media media volume should be able to dissolve at least 1500 mg of the API, and then you can say that sink condition is achieved. Now what is sink factor? So the generally required factor of 1:3 or 1:5 is for sink factor. That means in simple words, 3 to 5 times of the drug solubility should be there in the dissolution media. Saturated solution is formed, for example, in the 300 ml, then you can directly use 900 ml. These are the examples only. You can have your own calculation and then go for the dissolution media and media volume. API dose to volume of the media. So this is the simple meaning of sink factor. It is a ratio of the volume of dissolution medium to the dissolution volume of the drug being dissolved or tested. Here some examples I have included. Volume of the dissolution media to the amount of the drug being dissolved, or drug in the formulation of high strength being dissolved. Example 1. Solubility of API in the dissolution media as per the solubility studies is 0.05 mg per ml, and dose of the higher strength is 100 mg. Then to dissolve 100 mg dose, the volume of media required will be 2000 ml. Because considering the low solubility, the media volume will be high, and this will give you 1x or 1 factor. Then example 2, the solubility is 0.5 mg, and if you consider the same 100 mg dose, then with 200 ml you can get the 1x sink factor. And for this type of solubility APIs or this type of the solubility API formulation, you can use 900 ml media as a standard media volume. Example 3, the media volume is calculated based on the solubility studies, and solubility is 0.08 mg per ml. For the same 100 mg dose, the 1250 ml media volume will give you the sink factor of 1x. Now, if the dissolution media uh, required is more than the standard dissolution media volumes, then you can go for the surfactant use. So use surfactant to get the media volume of around 900 ml or 1000 ml, because lot of justifications are required if you are using the dissolution parameters beyond the standard ranges. Solubility of API in the dissolution media with 0.2% SLS as per the solubility studies is 0.11 mg per ml. You have used the surfactant and you increase the solubility. Dose of the higher strength is 100 mg, then dissolve 100 mg dose in the volume of media required will be 909 ml. So that time you can go for 300, you can go for 900 ml media. It will also give you the 1x sink factor. If the same media is used for 50 mg strength, then the as per the sink factor requirement, then only 450 ml media can be used. So can we use it, or can we increase the media volume to 900 ml? So other way makes the surfactant concentration half, as the dose is half of the higher strength. First thing is to get the sink condition of at least 3x, and then you can decrease the surfactant level as per the strength. Many of the time sink factor required to be kept similar for the strength to get the meaningful dissolution results and to avoid the chances of less discrimination or no discriminatory power for the dissolution method for lower strengths. This can happen for the formulations which contain the low soluble APIs. Example here I have included is a tablet of 150 mg, and you have used, for example, the surfactant level of 0.75% in 900 ml media, and you got the sink condition. Now other strengths or lower strengths are 100 mg and 50 mg. So directly you can decrease the surfactant concentration to maintain the same sink factor. And this is because this is crucial to prove and justify discriminatory power and biorelevance. Also important for combination product made with soluble and insoluble drug combination. If your formulation contain the combination of soluble and insoluble APIs or combination of insoluble APIs, that time it becomes very important to have the discriminatory power for each strength. Strength dependent dissolution to maintain the same sink factor. Many of the time we hear that and we observe that for the lower strength the dissolution becomes faster, and for the higher strength the dissolution becomes slower. Many of the times because of the sink variation or less sink condition at higher strength and higher sink condition or higher sink factor at lower strength can be responsible for these type of observations. Now we'll see what is the importance of sink condition. So as we know, sink condition is required to avoid the saturation of the dissolution media, to avoid the chances of the dissolution failure, chances of incomplete dissolution. It is also required to get reliable and reproducible dissolution results, to get good correlation between the in vitro and in vivo data. To maintain the sink condition throughout the dissolution run is very much important. Then only you can get the good dissolution profile. And it is critical for the new and generic drug products for regulatory approval purpose. Sink condition is most crucial and critical for BCS class 2 and 4 APIs. So this is regarding the sink factor in dissolution testing. I have made some videos on sink condition and non-sink conditions. So also watch those videos to have good understanding. Thank you for watching the video, and please do like, share and subscribe to this channel. Thank you.